We like to think of science as this big, beautiful library where almost all the books have been written and neatly filed away. But what if I told you that some of the most important shelves are completely empty? That we have real, logged, verified observations from our best instruments that just plain don't fit? Yeah, let's get into it.
And this quote just nails it, doesn't it? We're not talking about myths or stuff you read on some weird corner of the internet. We're talking about those moments when our best tools and our brightest minds look at the hard data and have to admit something here is seriously wrong with the picture.
But see, these anomalies aren't failures of science. Not at all. They're actually proof that science is working exactly how it's supposed to. Honestly, they're the little signposts at the absolute edge of what we know. So today, we're going to take a tour of that edge, and we're starting with some strange whispers from the cosmos.
Okay, so our first set of anomalies comes from way, way out in deep space. These are signals and events that we have absolutely detected, we've recorded them, but for the life of us, we can't explain them. They're like echoes from an unknown source just ringing out in the silence.
I know, it totally sounds like the opening of a sci-fi blockbuster, but I promise you, this is a true story. A single, incredibly powerful, and very, very unnatural broadcast from the stars that showed up once and then just vanished. So picture it. On that night, a huge radio telescope at Ohio State University was listening to a quiet patch of sky near the constellation Sagittarius. And then, bam! For exactly 72 seconds, it recorded a signal that was completely unlike anything it had ever heard before or has ever heard since. And that is exactly how it got its name. When an astronomer named Jerry Ahman was reviewing the data printouts a few days later, he was so stunned by what he saw, this perfect, intense signal, that he just circled the code on the page and wrote a single word in the margin, wow. I mean, can you imagine that feeling? Just pure jaw-on-the-floor discovery. So what made this thing so wild? This chart really breaks it down. See, natural signals from space are usually messy and spread out, kind of like radio static. The wow signal, though, was laser-focused, strong and clean on a single frequency. Also, natural things tend to repeat or flicker. This thing appeared, held rock steady for that minute and 12 seconds, and then poof, gone. After decades of looking, we've never found a natural source. We've never heard it again. The wow signal was this incredible one-off. But what if the universe is full of these mysterious flashes? Well, turns out it is. And in 2007, we discovered a completely new type of event, something so energetic it makes our own sun look like a little firefly. They're called fast radio bursts, or FRBs, and they are just mind-bogglingly powerful. We're talking about a flash of energy that lasts for maybe 1,000th of a second, but releases as much energy as our sun pumps out over several days. Some of them flash once and are never seen again. Others repeat, like a cosmic beacon from the same spot billions of light years away. We have theories, sure, crazy stars called magnetars, maybe collisions, but no single idea fits all the data. We didn't even know this was a thing that happened in the universe until just a few years ago. Okay, so let's shift gears from mysterious signals to something even more fundamental. What if the basic rules of the universe, the very forces holding everything together, aren't quite what they seem? All right, here's a fact that is genuinely disturbing. Based on our understanding of gravity and all the stuff we can see, galaxies are spinning way, way too fast. The stars on the outer edges are moving so quickly they should just get flung off into the void, tearing the entire galaxy apart. But they're not. They're just staying put. So scientists team up with an idea. There must be more stuff out there, a whole lot more, that's providing the extra gravitational glue to hold it all together. They called it dark matter. Not because it's evil or something, but because it's literally dark, invisible. It doesn't give off light. It doesn't block light. We can't see it or touch it. The only reason we know it's there is because we can see its gravity yanking on everything we can see. And this is where it gets truly wild. All the normal stuff, stars, planets, you, me, everything we have ever observed in human history, that makes up only about 15% of the matter in the universe. The other 85% is this mysterious dark matter we've never even detected. Just think about that. We're living in a universe, and we have no idea what most of it is even made of. So we've gone from the biggest things in the universe. Now let's zoom all the way down to the absolute smallest, the quantum level. And down here, we find maybe the single weirdest, most counterintuitive, and yet experimentally proven fact in all of science. It's called quantum entanglement. This was so bizarre that even Albert Einstein couldn't stand it. He thought it was just too weird to be true, and he famously called it spooky action at a distance. He was sure we were missing something, some hidden information. But here's the kicker. Every single experiment we've run since has proved that Einstein was wrong. The spooky reality is just reality. So here's how this mind-bending thing works. You link up two particles, so their fates are forever intertwined. Then you separate them. It could be across a room, or it could be across the entire galaxy. The distance does not matter. And here's the spooky part. The instant you measure one particle, you immediately know the state of the other one. Instantly. It's a connection that seems to break the cosmic speed limit, and it challenges everything we think we know about space and time. For our final section, we're going to turn the telescope both inward and outward one last time. We're going to look at anomalies found deep inside our own minds and out in the profound, silent emptiness of the cosmos. So this anomaly isn't happening out in space. It's happening right behind your eyes. It's the placebo effect. Now, we all know the basic idea, right? Giving someone a sugar pill and telling them it's medicine can make them feel better. But the really disturbing part is that it isn't just a feeling. The effects are real, and they are measurable. We can put someone in a brain scanner and watch their brain chemistry physically change. Their hormone levels shift. Their immune system can actually power up or power down. A simple belief, just an expectation, can trigger a whole cascade of real, tangible changes in your body. We can watch it happen, we can measure it, but we can't fully explain the mechanism. How does a thought literally become a molecule? We have no idea. And this brings us to our final, and maybe the most existentially unsettling anomaly of all. It's called the Fermi paradox, and it starts with a very simple calculation and ends with a very, very profound silence. First, just try to wrap your head around the numbers. We estimate there are over 100 billion galaxies in the observable universe. Each one of those has hundreds of billions of stars. And we now know planets are everywhere. So when you do the math, the universe should be absolutely teeming with life. It should be a noisy, crowded, bustling place. And yet, when we listen, all we hear is silence. No signals, no probes, no evidence of anybody else out there at all. Just nothing. That's the paradox. All of our logic says the universe should be full of life, but all the evidence says we are completely alone. It's called the Great Silence. So after that whole journey through cosmic signals, invisible forces, and this huge existential silence, what's the takeaway? It's easy to feel a little unsettled, sure, but these anomalies aren't a reason for despair. They are a reason for absolute excitement. This is the honest frontier of science. Every single one of these puzzles exists because a scientist somewhere measured something carefully and refused to ignore a result that didn't fit. These aren't failures. They are invitations. They are the shadows that prove there is still a vast, brilliant light of discovery just waiting to be found. And accepting that we don't have all the answers isn't weakness. It's the very first step toward finding them.